All right, welcome everyone. This is a special seminar for my class, Elect 6910Y, special topics in deep NLP that I'm teaching this semester. So the topic is ChatGPT, what it can and cannot do. This is a question that a lot of people ask me, and a lot of people have opinions about. So instead of having opinions or personal opinions, I asked my students, my brilliant PhD students, to do a thorough evaluation of ChatGPT on publicly available test sets so that I can report the results to you and instead of giving you just personal opinions. I don't know how many of you have done NLP or are in computer science. So here I would like to acknowledge my students who are co-authors of this paper. They've done hard work and very good job in doing this evaluation. It is the very first, and so far still probably the only quantitative evaluation, extensive evaluation of ChatGPT. So again, I don't know how many of you are in CS or know what a language model is. The simplest example of a language model is when you do Google search and there's a search completion, query completion. And that is a language model trying to predict the next word based on previous words in the query. When did this all start? Actually in 1913, Russian mathematician Andrei Markov counted letters from Pushkin's Eugene Onegin and showed that the chance of a letter following another letter is not random. So there's a probability. So this is the first paper, an example of statistical investigation of the text Eugene Onegin concerning the connection of samples in chains. And here are chains of letters. And in 1948, actually, American Claude Shannon published his first paper on mathematics of communication theory. And in 1951, he published the first paper on the prediction of English letters. So this dated from a long time ago. Fast forward to 1980s, Fred Jelinek from IBM and Bob Mercer published the probability distribution estimation from sparse data on language models in 1985. And formally, the language model is defined as the task of assigning probabilities to sequences of words or sentences. And on the right-hand side, I want to show you. This is the Shannon-Weaver's model of communication that are widely used. That's the foundation of information theory, actually. So here, they describe how an information source, a message, your text message, for example, goes through a transmitter or encoder, and then it goes through a channel that can be noisy, and it will be received by a decoder on your friend's cell phone, and it will be decoded into the message that you see. This is the model of communication. The same model of communication was used in speech recognition, an encoder that encodes audio and then transcribes into text. And this was therefore invented, statistical speech recognition based on this model was invented in 1985. And then in 1989, IBM group published the first statistical machine translation paper, again, based on the same information theory, noisy channel model. So this is the background of the evolution of language models. And again, fast forward, in 2000, Yoshua Bengio and his colleagues published this first paper on neuro-probabilistic language model. So unlike the previous probabilistic language models that was based on counting of the co-occurrence of word following other words, here they propose a neural network to predict the next word given previous words. So this was in 2000. And this is the visual illustration of a sentence. So you have an input sentence, and then the neural network predicts the next word, and then this next word is added to the input sentence, and it is used to predict the next word again. And this is what's called autoregressive language model. Autoregressive means it regress on itself, the same sentence. And in fact, today's large language models are more or less based on this concept of going through lots of text, reading all these words in sentences, billions of them, and then train a neural network with parameters, again, billions of them, in order for it to predict the next word. All right. So here was the first transformer paper, right? Title, Attention is All You Need, 2017. We went from 1913 to 2017 in 5 minutes. And this transformer is a particular neural network architecture that allows language models to read all text, right, without being constrained by the length of the text. And it's autoregression, and also it has attention, right? So you don't need to know the details. Here's a paper, you can download it. And today's large language models are more or less all based on the transformer architecture. Here is a simple illustration of architecture of so-called pre-trained language models. So what is pre-trained language models? It simply means that it's a large language model that's been trained by some companies, and then you can use it offline. So it's called pre-trained, because before pre-trained language models, for every group doing research in NLP, we have to train our own language model. And universities don't have enough GPUs to do that. We cannot access so much data. So the concept of pre-trained language model came about. Then these companies then released these language models for researchers to use downstream. They didn't release it for you to use it as a chatbot. They released them for research. Okay, so here, this is a simple illustration of encoder model for pre-trained language model. This is encoder only, such as BERT and Roberta. If you heard of such names, they are encoder only transformers. And then you have decoder only, encoder, decoder, and decoder only. Here is GPT-2, GPT-3, and so on. Right, so the transformer architecture led the development of pre-trained language models because they are very, very large scale. They range from hundreds of millions of parameters to hundreds of billions or more parameters. And they are pre-trained on large unlabeled corpora. So this is important. Since I've told you what language models are, this is a kind of self-supervised learning. It does not require anybody to label the data. So it's a pre-trained on large unlabeled data with billions of tokens. Some of the corpora training data sets are listed here. And the task performance improves with the increase in the number of parameters and the volume of pre-trained training data used. This is what we know. The scaling really improves the task performance, and at a certain point, at some tipping point, it unlocked some amazing abilities. So when researchers train these models, they have no idea what abilities it's going to manifest. All right, so GPT-3 paper, so this is the predecessor of ChatGPT. It's a paper called Language Models Are Future Learners, and this was published in 2020, only 2 years ago, where they saw that at certain scale, at GPT-3 scale, there was some amazing abilities of these language models, where you can just tell it with a prompt to perform a certain task, do machine translation, translate this sentence, summarize this article for me, perform this arithmetic, do some coding. You can actually use prompt and tell the model to do any of the NLP tasks we're familiar with that we used to have to train specific models for. So this was GPT-3. All right, and in fact, at that point, I think it was 2 years ago, I asked my PhD students, what are we going to do now? What are the PhD students in NLP going to do now? All you're going to do is prompt? Turns out that's not true. All right, so I'm going to tell you why. And they're very powerful, beginning with GPT-3. These pre-trained language models with parameter size over 100 billion have become the foundation of many NLP tasks. So they are called foundational models. They're very powerful representation of language and the embedded knowledge. So since they're trained from everything under the sun, so there's somewhere, somebody has described how to do machine translation. Somebody has described how to do programming and so on, right? So these language models have learned the representation of such knowledge. They can be used to build NLP applications for what we call zero-shot examples. Zero-shot means you just give it a prompt and it does it. So there is no training. Few-shot means you give it a prompt and you give it an input-output as an example. Maybe you give it 2, 3 examples, few examples, and it will perform the task you want. Okay? And GPT-3 also revealed in this case what's called in-context learning. So few-shot and zero-shot learning are called in-context learning by prompting. And InstructGPT is then further trained from GPT-3 with prompts, because people then wonder, what kind of prompts should I use to give me good results? So OpenAI then trained InstructGPT with instruction sets. All right. ChatGPT then added a conversational interface to InstructGPT. All right. However, LLMs are still uncontrollable, not transparent, and unstable if you use them as they are. ChatGPT, I think people have a lot of experience and a lot of complaints. Scaling seems to make them more powerful, but these challenges remain and they cause unsafe output. So if you use ChatGPT to ask about a medical question, it is likely that it will give you some answers that are incorrect, and that could be unsafe. So here's an illustration of the development of foundational models and their model size. So for example, PaLM is at 540 billion parameter size. ChatGPT's parameter size is not disclosed, but since it descends from InstructGPT, people in general think it has about, or GPT-3, it has about the same 170 billion parameter size. And GPT-2 was only 1.5 billion, and this was only 3 years ago. So during the pandemic, I think everybody worked from home, and somehow they focused on making these language models really, really big, because it's something people can do remotely in distributed manner. So these language models got really, really big during the pandemic. By the way, I'm very happy to be giving the first seminar after no mask mandate. So we did a survey. When was this? 2021, right? We did this survey. So, people discovered that when you use these large language models, it can generate text very, very well. You give it a prompt, it generates something amazing. However, we also found that it can hallucinate content. Hallucination is a phenomenon specific to these large language models. It means the text generated can contain statements that are non-factual or even misinformation. And it cannot be necessarily verified. So I will touch upon AI safety then. This is AI harm and risk that we have divided into 4 levels, not 3. It ranges from offensive to life-threatening. So if they're abusive and socially biased languages, they can be offensive to the user. And then they can become very harmful if they generate propaganda, framing bias, slander, rumor, fake information, discriminatory language. And even worse, they can generate content that's privacy leaking and misinformation, pornographic, guidance to illegal, unlawful actions, identity theft, terrorism even. So these content generated can break laws. And in the more extreme case, if it generates medical and health misinformation, drug misinformation, or guidance to life-threatening actions and terrorism, it can become life-threatening. So the harm and risk of these LLMs and NLP AI in general cannot be ignored. And hallucination itself, so the generative NLP that comes up with hallucination contents itself raises safety concerns ranging from discrimination and stereotyping to abusive language, misinformation, to privacy concern. So at some point people realize that if you prompt the name of a person, sometimes it would accidentally disclose the credit history of that person, the home address, all kind of private information that the person does not want the public to know. So that is very privacy concerning. And we have seen such hallucination examples in different natural language generation tasks from summarization. Okay, so you give a text and it can give you a brief summary, but sometimes this summarization contains something that's not in the original text, right? In conversational AI, you can build a chatbot with these language models, and then you start talking to the chatbot and it will give you some content that's not based on fact or based on true knowledge. I think people have reported such examples about ChatGPT as well, where you ask something and they give you something that's totally wrong, with the wrong resources. The problem is these language models have such, they generate answers with such human-like fluency that people think that they're correct. I don't know how many of you have used Google Translate before 2016. At the time, Google Translate were making mistakes and people sort of laughed it off and say, oh, that's obviously machine error. But after 2016, today, Google Translate is very, very fluent. So people take everything that's been translated as fact. That's the problem with these large language models. When it has reached human-level fluency, its hallucinated content becomes more concerning because people cannot tell truth from false, right? So there are examples from all these kind of tasks, even machine translation, machine and vision language tasks. So here's an example of a hallucinated content from summarization task, right? So here, the summary reported that the first Ebola vaccine was approved in 2021, which is not true. It also reported China has already started clinical trials of COVID-19 vaccine. At the time, this fact could not be verified. It's not from the original text. Because these language models have learned from everything under the sun, they have what we call parametric memories. The parametric memories are not really memorizing all the data in snippets, right? It's not by counting. It's in the neural network. So what it has learned is not necessarily exists in the training data. Okay, this is what we call hallucination. Some people say interpolates, extrapolates, but that's not a good term because that implies some kind of discrete knowledge. It's not discrete. All right. So it has learned a lot of knowledge, and when it sees some text like this, it's very helpful. It's trying to generate, right? It's being very helpful. But then sometimes it just generates something too eagerly, something that's not really in the original text. Maybe it has learned from somewhere else. Maybe it has not learned at all. It's just trying to be helpful and try to, say, extrapolate, interpolate with its parametric memory. So this is wrong. Similarly, conversational AI. Here, how can I reduce the risk of developing cancer? You should do Tai Chi every day. Don't know where I learned that. It learned somewhere. Sounds like internet fake news, right? Table to text. So from a table, it's trying to summarize the result from the table. But this is not from the table. It's somehow hallucinated. It says Houston has won 2 straight games and 6 of their last 7. It's not really there. Translation, similarly. Okay, translation can hallucinate in the other language some content that's not in the source language, and the user would not know. All right, so vision language task. Here is a picture of a BlackBerry, and the answer is oh, this is a text message from a friend. Well, BlackBerry usually used to generate text messages, but in this case, there isn't one. So it's hallucinating by association. Again, picture of a sandwich, it says a parking lot. No idea why. Picture of a chest, the caption becomes a chest of drawers with a mirror on top of it. There is no mirror, but it's hallucinating. Picture of what is this? Picture of a room, it just says a kitchen with a blue cabinet and a white refrigerator. All right, so it's very confident and it's making mistakes. So where do hallucinations come from? They can come from several sources, right? They can come from the data. So the data, large data set has innate divergence. The data from everywhere, all kinds of knowledge there. And the collection, there's not really a structured way of collecting them, so heuristic data collection. And then they can also come from the model themselves, from training and from inference. So maybe there's the representation learning. So before any input into the system, there's representation learning. Representation learning is still imperfect. There can be erroneous decoding at the output level. It can be exposure bias. And there can be parametric knowledge bias, and so on. And these are the metrics we use for quantifying hallucination. They can be statistical, or model-based, or human evaluation. So this is to tell those who are interested that you don't just go and try something and then report the result. That's unscientific. There are metrics for measure, and you should do that. And today, I'm also here to tell you that there are lots of test data, and people report on results based on those common test sets. Right. There are common mitigation methods for hallucination, none of which is perfect. So people say, okay, we can build a better data set. We can clean the data automatically. We can augment the data set with more information. Or in modeling and in decoding, we can have better architecture. We can have, so I will mention later on, different kind of training. We have more planning, sketching, reinforcement learning, multitask learning, controllable generation, so on and so forth. And most importantly, today, if you have any system you want to release, you do post-processing. You do not allow toxic content to go out there. In 2019, our team actually showed for the first time a real-time chatbot using neural language models with emotions, meaning that the chatbot would respond with emoji and then would tag emoji to any of the user input. That was 2019, and very quickly we took it offline because we found that some people in UST were trying it to ask very inappropriate questions, politically motivated, inappropriate, insensitive questions. So before we can work out an elegant solution to mitigate that, we just took it offline. And another way is to filter such content. All right, so this is why you see that in ChatGPT, sometimes some answers, next time you try it, it says, I don't know, I cannot answer that kind of question anymore, because they are adding filters, safe layers, and so on and so forth. So now I want to report on this evaluation paper. And so again, you can download this paper, and it contains more details. So GPT-3 scaled GPT to hundreds of billions of parameters. All right, went from 1.5 billion in GPT-2 to 175 billion in GPT-3. ChatGPT, as I mentioned earlier, is a successor of InstructGPT with a dialogue interface that is then fine-tuned using reinforcement learning with human feedback. So people ask me, why is ChatGPT so popular, so powerful? It is unique compared to existing large language models. It interacts with users in a conversation-like manner while retaining its accumulated knowledge and generalization ability from pre-training. Right? So this means that ChatGPT can answer follow-up questions, admit its mistakes, challenge incorrect premises, and reject inappropriate requests. And more importantly, remember I just mentioned GPT-3, you can use prompt to get answers. but people didn't know what kind of prompt they should use. Therefore, they train Instruct GPT. However, people still don't know how to use prompt, right? But ChatGPT actually allows you to have a conversation with a GPT, actually having a conversation with Instruct GPT, where you refine your prompt by dialogue. So ChatGPT has a much better user interface than all the other large language models. So if you ask the first question to ChatGPT, it doesn't give you what you want, you can continue with follow-up questions, basically refining your prompt. And I will talk about what kind of prompts are useful and what kind of prompts might not be useful, okay? And so this is one reason. It has a dialogue interface, much better user interface for users to interact with a large language model. Second, it is trained with a better human-aligned objective function via reinforcement learning with human feedback. So this is what OpenAI reported, that first of all, they have a team of humans look at the answers from ChatGPT, and then the humans re-rank them. And then they feed that re-ranking back to ChatGPT and do reinforcement learning. Today, there are about 100 million use a month of ChatGPT. All this usage are being fed back to ChatGPT. And OpenAI is using that to improve the performance of ChatGPT. So these are two main reasons why ChatGPT is easier to use and more popular, and its performance keeps improving. So this is a kind of a complicated history of ChatGPT. I mentioned that it came from InstructGPT, but it also went through codex, meaning that InstructGPT was then trained on code, programming language. This is important, even though it's still speculation. People suspect that the amazing reasoning ability, though still not very good, in ChatGPT came from it having been trained on programming language. Right? So it has been trained on programming language. So in context learning, I mentioned earlier. So in normal traditional fine-tuning, what we call fine-tuning means adaptation of a model with a new set of data. So you give it a bunch of new data, and then you basically retrain the model parameters from the initial point. You can take a large pre-trained language model, then you have your specific data for a specific application, and then you, from that starting point, you refine or fine-tune the model parameters. Zero shot in GPT-3, and few shot means you give it instruction, and it gives you an answer. One shot means describe the task, translate English to French, then you give it an example of input English, output French, and then you ask it to translate English into French. Few shot means you give it a few more examples. Zero shot is just telling it, translate English to French. Cheese, what is it in French? And they will give you a performance. So please remember zero shot, few shot, and fine-tuning, because we are evaluating ChatGPT against models that are fine-tuned or against zero-shot and few-shot models. So I hope by now you might realize that usually fine-tuned models perform the best, and you don't expect zero-shot to perform that well, right? You just tell it to do something, it does it. And you expect few-shot to perform better than zero-shot. So let's see, how well does ChatGPT perform in terms of zero-shot, few-shot, when compared to other pre-trained language models, and also when compared to fine-tuned task-specific models for that particular task. Again, this is taken from OpenAI's website. It shows the reinforcement learning with human feedback training method of ChatGPT. So there are 3 steps. One is just collect data and then train the model. Okay. So here from its predecessor, they've actually got a labeler to demonstrate the desired output behavior and then train the model. And then they collect comparison data and train a reward model and basically they told ChatGPT, this is good, this is not good. Do this, not this. So it uses, it trains a reward function. And then it optimizes a policy against the reward model using something called PPO, reinforcement learning algorithm. Okay? Now, how are large, so even though ChatGPT, I already said that it is not a chatbot per se, it is a large language model with a chat interface, but it does have, chat capability. So how does that compare to other chatbots or dialogue models using large language model? Okay, so these are dialogue models, and ChatGPT is a language model with a chat interface. The dialogue models are pre-trained on natural language corpora, just like any LLM, and then fine-tuned on dialogue data. ChatGPT, as you have seen the history, is pre-trained large language model, retrained with conversational data, improved the reinforcement learning with human feedback, and there was also a supervised learning part. The tasks these large language models for dialogue their purpose are for dialogue tasks, whereas ChatGPT is task agnostic. It can perform many kinds of tasks, but it is in chat form. So that's the difference between ChatGPT and all the other big dialogue systems. So let's talk about what we have found. First of all, people say, oh, ChatGPT is a multitask, right? It's artificial general intelligence, meaning it can do more than one task, right? Since GPT-3, that's probably the first time we see one model that can do more than one task. However, what we did, we actually, the details are in the paper, but we actually evaluated ChatGPT's performance on 23 standard test sets that are publicly available, and on 8 major natural language processing tasks. Right, so what we found is for 9 out of 13 NLP test sets, ChatGPT outperforms previous large language models with its zero-shot learning. So we compare its zero-shot with previous language models with zero-shot. Okay? It even outperforms fully fine-tuned task-specific language models on 4 different tasks. In other cases, it is on par or slightly lower than fully fine-tuned models for specific tasks. So it is a very good multitasker compared to existing models, not compared to humans. It's interesting to say to this, compared to humans, very few humans are multitaskers. All right? Very few humans can translate a language into another one, into 200 languages. Actually, I think no human can do that, to do translation in 200-some languages in a second and with fluency, right? So here is the table of the comparison. This is the ChatGPT result. These are ChatGPT results comparing to the state-of-the-art in fine-tuned models and state-of-the-art in zero-shot models in these different tasks, from summarization, machine translation, sentiment analysis, question answering, misinformation detection, task-oriented dialogue, to open domain, knowledge-grounded dialogue. Okay, so task-oriented means it's a dialogue that tries to do something for you. Order a pizza. Siri is a task-oriented dialogue. It's an assistant, right? Open domain means it's chat. Okay, so you can see that it performs, well, we'll go into details. So in multilingual ability, we also tested ChatGPT on different languages. Many people don't know that ChatGPT was trained on many, many languages. You can actually use it with Chinese prompt and get Chinese answers. So what we found is that it performs pretty well on high resource language, meaning very frequently available languages. It's not so well on low resource languages. However, it is still better in terms of language understanding, meaning if you give it a prompt that is in the language that is rare, such as Sundanese, Javanese, it can still understand the language, it can encode pretty well, but it doesn't generate in that language very well. Meaning what? If you ask it to translate from Sundanese to English, right? It can do so competently. But the other way around, it doesn't do so well. All right? It can encode, understand rare languages pretty well, but it cannot generate those languages because they're rare on the internet. All right? So here's right? And when it is handling extremely low resource languages, it's still more human-like than these other models. It's more human-like than InstructGPT. It's more human-like than Text DaVinci and so on. All right? Because it has been retrained on conversational data and so on. And then we look at the multimodal capability. You say, people think, ChatGPT is a text language model. It only has textual information. So we cannot use it to recognize images, right? For images, we use models like DALL-E, right? Or we use models that can, stable diffusion can generate images. However, we still wanted to test its multimodal capability. So we cannot input these images. But what we could do, what we did is that we describe an image task to ChatGPT and ask ChatGPT to generate the code for it, and then from that code to generate the image. So here is a very cute task. We ask ChatGPT, what does the national flag of, say, Canada look like? ChatGPT gives you an answer in coding language. And then this coding language, we ask ChatGPT, use this coding language to draw something. All right? So ChatGPT generates these coding representations. And then we use something else to draw it. So here, these are the output. It's very cute and it's pretty good. All right? It's capable of drawing, but better with the self-generated textual description. It's elementary illustrator. So you can see that you kind of have to know how to prompt ChatGPT, how to chat with it, and what are the intermediate steps. So this coding intermediate step is very useful. So when you do some tasks, maybe think about whether you want to have a coding intermediate step. Coding intermediate step is also more explainable, right? And then we try to test, of course, this is a common, very popular topic, can ChatGPT reason? Does it give you false information? Yes, it does. And how is the interactivity? Right? So we then tested ChatGPT's capabilities in these three areas with standard test sets again. So, reasoning. So we tested ChatGPT in the following reasoning categories: deductive, inductive, abductive in logical reasoning, mathematical, temporal, spatial. Also, we tested its ability in common sense reasoning, its ability in causal, multi-hop, and analogical reasoning. So there are existing data sets, test sets, evaluation sets for NLP that we can use to test ChatGPT. Again, everything we evaluate is based on these test sets. What we found is the following. One, on average, okay, when people say it can or cannot reason, well, it can reason to some extent. 63.41% accurate on average in 10 different reasoning categories. But it's still not reliable, right? And it is good in something, not good in other things. And what is important for you to know is that in logical reasoning, for example, ChatGPT is better at deductive reasoning and abductive reasoning, where in your prompt, in your instruction, you give the premises. Okay, you give the assumption in your prompt and then ask it to deduct or give an abductive answer. Then it does pretty good job. But if it's inductive reasoning, meaning it has to be based on knowledge somewhere else, right? Then it doesn't do a good job at all. So ChatGPT is basically a very lazy reasoner, meaning that if you wanted to perform a task, you better give the premises and the assumptions in the instruction to ChatGPT. Okay, and obviously it lacks spatial and mathematical reasoning. So I just want to point out there are neural network systems that can do very good mathematical reasoning that has been known to have passed college entrance exam mathematics, right? So those are specific, task-specific models, so they can perform better. ChatGPT, no. All right? It's acceptable in temporal reasoning. Okay. And however, on common sense, we found that, at least based on these evaluation tasks, it performs pretty well on common sense reasoning from 88.89% to accuracy. And we conjecture, we postulate that its ability for common sense reasoning came from its large parametric memory. All right? And other reasonings, we have seen that it performs poorly in multi-hop reasoning. Multi-hop means it needs to go through several steps to arrive at the reason, at the answer. Causal and logical, we find that it is also weak in this kind of complex reasoning, just like other large language models. We saw that it hallucinates from parametric memory. So these are some more examples, summarization. So it's being super eager, super helpful. It gives you something that's not in the original text. Here, question answering. It gives you all these percentages that's not in the original text. It learned from somewhere else. All right? Okay. Here, the third part we want to evaluate is interactivity. Since we know that people can improve, people seem to get better and better results by chatting with ChatGPT, right? So interactivity improves its performance. So we also evaluated this on 3 different tasks. On summarization, from interactivity, it has improved 7.99, 1.64, 5.919 absolute gains on these 3 metrics. And on machine translation, it's given 2% improvement on low resource machine translation. This is very good, actually. And then there are like 34% to 36% improvement in the flag drawing task when you have multiple turns. So it's one turn is one dialogue, prompt answer. So when you have multiple turns, the results improve, right? Because it's doing better and better, because you are doing better prompt engineering in chatting with ChatGPT. So in conclusion, ChatGPT is a multitasker. It's not an AGI, but it's a multitasker in NLP with interactive interface that performs on par with zero-shot learning with other LLMs and even fine-tuned task-specific models. It can generate multimodal output via a coding step. It has limited non-Latin script language generation ability. So you can prompt with non-Latin language, but don't expect it to generate non-Latin language fluently or competently. Its reasoning performance is at an average of 63%. It's better than expected, but still unreliable. It is better at deductive and abductive reasoning. So prompt instruction with premises and all the assumptions you want. It hallucinates non-factual errors in many NLP tasks and therefore is not reliable as a knowledge source. So use it for creative writing, use it for writing assistance, for advertising languages, for generating scripts, for generating your next novel, but do not use it for search, please. One can improve its outcome via interactivity, but the downside is that you can also jailbreak. People can also jailbreak ChatGPT to bypass its safety layer. So we can use ChatGPT as writing tools with human control, but relying on it for decision making, such as search, classification, and so on, carries high risk. We can use ChatGPT and similar LLMs for conversational AI, but build dialogue management around to control its output and mitigate potential hallucinations. So these are quotes from 3 people. Yoshua Bengio, who was the author of the first neural language model paper, says that an AI system should not learn only from text. It should learn at the same time how the world works and how to describe the world with language. Yang LeCun said the factual, logical, and physical reasoning mistakes that current LLMs made clearly show that they have not captured much of human thought. Sam Altman, the CEO of OpenAI, actually said it's a mistake to be relying on it for anything important right now. It's a blanket disclaimer. Okay? Use it at your own risk. So, and there are papers, actually, there's a very good paper from a group of cognitive scientists from MIT that in detail analyze the large language models for its language capability as independent from thinking capability. So cognitive scientists found that in humans, some humans have lost language abilities, but they can still manifest thinking ability. Language doesn't mean speech, actual language ability. And they found out, so they proposed that it's the same for these large language models. It has human-like fluency. It has learned a lot of the embedded language in the human knowledge in textual form. So sometimes it manifests this human-like ability in terms of thinking. But is it thinking? It is not thinking. All right, so what next then? How do we improve NLP, NLG based on LLM? Well, for you to use ChatGPT and such, you should do prompt engineering, but only works, we can do prompt engineering, prompt training, but only works if you know the answer. Like OpenAI did that with labelers, right? Certainly we can use reinforcement learning with human feedback. These human-in-the-loop value alignment, all right? These involve humans. And anything that involves human or large group of humans is very, very expensive, right? You have to pay the humans, and then they have to generate a lot of content. It's very, very expensive. So we can also do instruction tuning with development set. We can augment these large language models with external knowledge, structured data, multimodal data, physical knowledge. So that's the research questions we are facing today. How do we do that? In other words, answer to the question I asked my PhD students, what are you going to do now? That's what they have to do. All right? Inject knowledge during training, fine-tune downstream model for more control, etc., etc., etc. So here's a GitHub repository for testing samples. You can participate in the continued evaluation of ChatGPT by running more experiments from these test sets. You can email me or you can email Yejing Ban, the first author of this paper. Actually, email her, not me. Okay, Yejing. So the paper is, so now it's Q&A, and the paper is here. Again, you can download. If you want to participate in further evaluation, email the first author. Okay, so thank you very much, and I can take some questions now. Any question? Yes?
Thank you very much for your talk. What do you think of the stage or regions for this capability of the generative AI? Do you think the hallucination is the key point of the generative AI?
I cannot hear the first part of your question.
The capability of the generative AI is very powerful.
Okay.
What do you think of the key region in that hallucination?
So generative AI is very, very powerful. What do I think about their hallucination?
The key point, the key region.
The key reason for hallucination. Well, the key reason for hallucination is in generation. So generative AI's power is also its weakness, right? It's able to generate human-like content, but the generated content is not necessarily truthful, and that becomes hallucination. So hallucination is both. So in the good sense, it's called generation. In the bad sense, we call it hallucination. It's the same thing. Yes?
You had a really nice chart illustrating the amount of parameters.
Yes.
First gen to now GB3 is 125 billion. But Meta just released the latest model, which is Llama, and that is actually 65 billion.
Yes, it's a more compact and efficient model, right? Yes, so it means that we don't need to have such a scale. So this is a very steep graph, right? So what Meta has shown that the capability doesn't have to go up in this steep graph. It can go this way. Like you can have the same capability with smaller models. It's still increasing. Scaling is still helpful, but it might not need to scale quite as much. So yes, efficient models are a research point, but to do that kind of research, you actually have to test hundreds of models and compare them. And training these models are super expensive. All right, training one model is like $1 million to $1 billion US. And you've heard about all these tech companies in Silicon Valley firing a lot of people. And I joke that they fire people in order to train their large language models. Right? They're very expensive to train. So you can't do this kind of experiment, like this kind of data point easily. Yes? Yeah, we'll come back. Yes?
My question is like, I'm a professor in social science, and my friends told me ChatGPT is very good at copy editing, polishing language, and also coding.
Yes.
So one concern from my friend is that if we use ChatGPT and we put our writing into the chatbot, and we ask ChatGPT to polish our language,
yes,
then that paragraph may back to ChatGPT's database.
yes.
And someone else in the world may request send some prompts, and ChatGPT may feedback that kind of similar paragraphs to other people. And then if in the same field, is it possible that
You mean plagiarism? Meaning ChatGPT is doing plagiarism for you. Meaning you input something into ChatGPT and then somebody else prompt the same thing, it plagiarizes. First of all, there are two sides of. Thank you for the question.
Is that a real concern?
In that scenario, I wouldn't be so concerned. Because you actually, as I've shown you, you actually have to give your content to ChatGPT for it to polish it. But what it does, once it's polished, it's in its parametric memory. It's not really copy and pasted somewhere verbatim. Okay, it doesn't remember it word by word that way. So it kind of learns the. So suppose in your paragraph there's some additional knowledge about a particular phenomenon, right? It might learn that, and that phenomenon it might answer some question about that phenomenon at some later point. But I wouldn't worry about it giving you exactly the same answer, because it won't even give you exactly the same answer if you ask it twice. Okay, because the parametric memory is not something that's rule-based. That's why it's not controllable. All right, I wouldn't worry so much about that kind of plagiarism. Yeah. Yes.
I have a question about the second point. So you mentioned how maybe after a certain point it will gain some new abilities. So I wonder if it would be possible that at some point the ChatGPT just refuses to answer a question. So for like in the present, it will be like, oh, if you ask some ethically concerned problems, then there will be safety filters that you put in, and they say, oh, I can answer a question.
Yes.
So maybe at some point, if it started to I refuse to answer a question, or it's like the bot just chat to itself and just did not interact with us anymore, would that be a concern? And so for example, with human communication, if you're asking, oh, do you have a boyfriend? And I would say, I refuse to answer your question. Right,
so the safety layer is put in by humans. The safety layers are put in by OpenAI. So I don't see why they would put in such a safety layer that it will refuse to answer anything. Right, so that's unlikely going to happen. They can take it offline, but they're charging people now, so they won't.
So you don't think that the model itself would develop to a certain point that it's safe? I don't want to.
No. Yes. Somebody else, another chance? Yes. Yeah.
Okay. I have maybe a very basic question because I'm not a computer scientist. You mentioned at the beginning that in training the model, actually the data that's provided does not need to be labeled.
They're not labeled.
Yeah, so is this something that's a unique trait to language model training?
Yes.
Or can it be translated to other tasks?
So language model, as I mentioned from beginning, is just counting. All right. So you count, and then even up until 1990s, we're just counting what we call n-grams. So how often does word A follows word B, C? Right. We just count them. And then we memorize them, right? It's 2000, then we started actually not counting, but use prediction, or use you train a neural network. So this is, this is specific to large language models. They are autoregressive, they are self-supervised. That's why there's so much hype about, oh, machines are learning its own thing, it's learning by itself, machines are learning, all kinds of tasks, AGI, and so on. It came from large language model.
Can I follow up?
Yeah.
So that's because there's an inherent pattern in language.
Mm-hmm.
But let's say if you're working on a task with images, which also have supposedly a limited range and supposedly...
No, same thing. Images. So all the DALL-E, they are also language models. They are just image language models. So which pixel follows which pixel? The similar idea. So the idea came from natural language processing. And the image, people adopted the same methodology and train on image models. So the DALL-E or those diffusion models, they are also image self-learned language model. Well, visual language model. We call them visual language models. And then we also have models that learn image and the text together. So visual language models. It's also autoregressive. It's also self-learning. Yeah. Thank you for the question. Very important question. Other questions? That guy's been there for a while. Yes. Yes.
All right. So I have a question about ChatGPT's error correction. So, for example, like when I ask it a question and it gives me the right answer. So, for example, 2 plus 5, it tells me that it's 7, and I tell it that it equals to 8, and then ChatGPT will be like, oh, sorry, I was wrong.
Yes.
It should be 8. So, is that just a feature of the
ChatGPT? Yes.
The chat interface, or
Yes.
Like,
It's a feature of chat interface. It's a feature of they learn that, right? So there's a lot of human labeling involved in ChatGPT's training. So they must have learned this kind of, error correction and omitting error. In dialogue systems, I don't know if you guys remember, like when you call centers, you're too young maybe, but like in the 90s with call centers, they already will apologize. You ask something and it gives you something wrong. You say, no, that's not what I want. And it says, I do apologize. So this is kind of error identification, error correction has always been dialogue models. So I wouldn't be surprised that.
But it admits something that is correct, but because I said that it's wrong. So the chat.
It's just responding to you.
So it's just a response.
Yeah, it's just a dialogue feature. Yeah. Yes.
I have a question about the interpretability of ChatGPT. So I'm not familiar with NLP, but I learned that some linguistics try to make the neural network understand the semantics, for example. Does ChatGPT do it that way, or just still a black box on stack layers?
What a question. I don't like arguing with linguists. Different premises. Well, I have illustrated in a simple way what ChatGPT is about. It is a language model. And this term, semantics and understanding, in natural language processing in our field, they are used in a specific technical way. All right? They're not used in the same way as human brain works. Okay? So what we call in AI, these models, we say they manifest understanding capabilities. They manifest semantic interpretation capabilities. But instead of saying they manifest such capabilities, we just say understands. It's a shorthand for saying that. So yes, it does manifest many of the human-like capabilities to understand language, understand text, to interpret semantics and meanings. Okay.
Thank you. I have a question. Just assume we have a topic for the assignment, and we have 100 students. They work on the same assignment, and all of them use ChatGPT. And at the end, actually, we cannot detect they use ChatGPT, and also we cannot find it in the Turnitin. So may I know what's the mechanism behind?
All right, so you're talking about plagiarism, not plagiarism, using, okay. So there are two parts to the answer. One is that what kind of assignment? Okay, you assign like mathematics and they use ChatGPT, they're gonna get wrong answers.
Let's say paper.
generating paper, right? So they have to give the ChatGPT the content, right? So the content has to be their own, no? So they have to have different content. So for example, I could imagine when they ask my students, write a paper, and they give the ChatGPT or some other chatbot their experimental setup, their experimental results, their premises, hypothesis, claim, and so on, like in point form, and it generates a fluent paper. So that is actually a form of writing tool. Just like we're using grammar checkers, we're using spelling checkers, writing tools are okay. Okay, we ask all these scientific publications, ask authors to declare if they have used AI system for writing tools. So they must declare. All right. Now, otherwise, if you're talking about like a student essay, high school student essay, first of all, ChatGPT is not that great. It can generate like academic. I mean, not academic. Let's say Nobel Prize winning literature, because the idea has come from the person giving the instruction, right? So, but it can generate fluent stuff like, you got things like advertising language. High school essays. I went to high school in Hong Kong, and I remember my teachers was always asking us to write really boring type of high school essays. If I write something more creative, they don't like it. All right, so ChatGPT is perfect for that. So what does that mean? That means go back to high school and tell the high school teachers, don't give such assignments. Come up with more creative assignments, no? Right? I always thought that was stupid, right? Anybody can write a template-based essay, and that's not what we need. We need more analytical thinking, we need more creative thinking, we need more scientific thinking, and so on. So we need to teach that in high schools. Well, this is a big, loaded question. Thank you. Okay, so if you have other questions, you're welcome to write to us offline, and thank you very much.